Well, this may come as a surprise to a lot of you. Gravity is an electromagnetic force. Yes, we've been lied to all along because physicists didn't do their research. And what didn't they research? They didn't research the cause of electromagnetic acceleration. When you have electrically charged or magnetized objects, something causes them to accelerate, either together or apart, depending on whether it's attractive or repulsive. But there's a physical mechanism responsible for this. Yet the physics community has not thought that it was important to understand this physical mechanism. And the same thing is true with gravity. There's a physical mechanism that causes gravitational acceleration. And they didn't bother to try to understand that. But you can't understand electromagnetic theory or gravitation without understanding the physical cause of acceleration. And yes, they'll say, gravity is not a force. Bodies just magically follow the curve of space. Well, space doesn't curve, and I did another video on that you can watch, because space doesn't have dimensions in the first place. But getting back to acceleration, if you think about objects like stars or planets, or you think about particles, they don't have jetpacks. This isn't rocket science. It's not a propulsion. They're not ejecting material so that they can move forward. They don't lose mass because they're being accelerated. And because they're being accelerated without losing mass, for example, say the Earth. The Earth's rotating around the sun. It's constantly changing direction. So in a classical sense, where it would have to eject mass continually in order to keep changing direction. And if that happened, the Earth would lose all its mass and get pushed into the sun very rapidly. The Earth wouldn't have existed from a long time ago. So that's not what happens. There's something else that's pushing the Earth toward the sun continually. And we have only one thing in space, the vacuum of space, that's the possible suspect for doing the pushing, and that's the quantum field. We have quantum fluctuations in space. Space, even the vacuum in the emptiest region of space, is not empty. It's filled with quantum fluctuations and a quantum field that has a tremendous amount of energy. And these quantum fluctuations interact with each other. Now, to understand the force mechanism that causes acceleration, that causes motion, it's best to start with the only force in the standard model theory that actually includes the mechanism, and that's the Casimir effect. In the Casimir effect, two plates can be pushed together because quantum fluctuations between the plates don't fit. And that reduces the pressure pushing the plates apart, so the pressure from the outside pushes the plates together. And in some configurations they can be pushed apart because they increase the pressure in between. And the pressure is coming from van der Waals interactions because the quantum fluctuations themselves interact like electric charge dipoles. So the positive, if I have two positive parts of dipoles together, they can repel. And two like parts together, or opposite parts, they can attract, which causes the quantum fluctuations to jiggle a little bit, which produces pressure in space. And this pressure is what pushes the plates together, or apart, as the case may be. So this is an actual real physical mechanism. You have quantum fluctuations interacting with matter, causing acceleration. The quantum fluctuations are doing work, really. So now if we reassess what's going on with electromagnetic acceleration, we find that electromagnetic acceleration, all forms of it, not just the Casimir effect, are due to this same quantum force pressure differential system. If you think about the Faraday field lines between two like charges, they curve upward because they're repelled from each other. Because you can't have two like charges next to each other, they deflect. And then the region of space in between is boiling with more quantum fluctuations that fill that region, which produces pressure pushing the two objects apart. So you have a situation where the pressure going outward is greater than the pressure inward, and the charges move apart. Now, when you have opposite charges, you get a different scenario where there's less pressure pushing the charges apart. And over time, the number of quantum fluctuations in between gets reduced, or their size gets reduced, and the charges get pushed together. And the same thing happens with magnetic situation. In between like magnetic poles, north to north or south to south, you get a greater repulsion than you do of pushing together, and it causes the magnets to become repelled. And then we also have when you have opposite magnetic charges, north to south, then they get attracted. There's less force pushing them apart. And so using the Casimir effect as a model and extending it to all of electromagnetism, it's possible to understand how electromagnetic theory works. And I just did a video on that where I talk about it in a little more detail. So anyway, now using this model, we can understand how acceleration works. So the next step is understanding what happens between electrically neutral bodies. Electrically neutral bodies also can create force differentials because they shadow each other. You have a body here and a body here, and you have forces coming from outside. This body shields this body from the forces going this way, while this body shields this body from the forces going that way. So the amount of pressure hitting this one is reduced, and the amount of pressure hitting this one's reduced, so that the pressure pushing them apart is lower than the pressure pushing them together. And this effect was first discovered in the 1690s by a man named Fatio, and then later it was revived by a Frenchman named Lesage, who may have come up with it independently or may have stolen it from Fatio. We're not really sure at this point. He was aware of Fatio's research, at least later. So we have a case where electric forces cause electrically neutral bodies to be pushed together. Now, the Fatio effect was denied for hundreds of years because they thought that the corpuscles that Fatio imagined in space would heat the bodies and would ultimately vaporize them if it transferred heat the way they thought, if their ether behaved like a kinetic gas. But in quantum field theory, the quantum field does not behave like a kinetic gas. It does not heat objects. The Casimir effect exists, and we don't get vaporized because the Casimir effect exists. If it did, I wouldn't be here. None of us would. So that's been, the heating argument is an entirely false assumption. And the corpuscles that Fatio imagined are quantum fluctuations. So all along, Newtonian type gravity, the acceleration of two particles together, has been an electromagnetic phenomenon because the pressure comes from electromagnetic interactions. Now, I kind of skipped over a problem with the attractive theory because van der Waals forces and the Casimir effect are short-range forces. While in order for electromagnetic acceleration to occur in this manner, there has to be a long-range force that obeys the inverse squared law. And we can see the problem if we consider an electron-positron. If you have electron-positron quantum fluctuations in pairs, that in one orientation where their like charges are together, they repel. And if they were always aligned in a repulsive configuration, that would obey the inverse squared law. But they don't. In reality, they can flip over and have opposite charges together and be attracted. Or they can be end-to-end and they can jiggle. So the regular van der Waals forces are short range. And we need to come up with a way to understand how we get long range forces. That's very easy to understand when you consider there's more than one type of quantum fluctuations. The two basic types are electron-positron and proton-antiproton. And when those two are together, we have the same situation. When they have like charges together, they repel. But when they flip, electrons and protons repel. If they didn't, hydrogen wouldn't exist. There is some form of repulsion that causes a potential barrier that prevents electrons from falling into protons from a merely Coulomb force, the electric force. And it's this repulsive force that means that an electron-positron quantum fluctuation and proton-antiproton quantum fluctuation are always repelled from each other. And this continuous state of repulsion is what produces a quantum field pressure that obeys the inverse square law. And it's that pressure that causes the electromagnetic acceleration and causes electromagnetic acceleration between electrically neutral bodies that's consistent with Newtonian gravity. Now we still have general relativistic effects to consider. And with that, as I mentioned, space by itself, by literary definition, is a boundless region that contains all matter. Space by itself is not physical. Einstein only imagined it's physical. There's no evidence that space has any physical nature to it. It has no dimensions. It has no clocks. Pixies don't magically sprinkle pixie dust and have rulers show up in space, or clocks. The rulers and clocks of space come from the wavelengths and frequencies of the quantum fluctuations. Wavelengths in distance, frequencies are in cycles per second. And the quantum field is self-regulating so that the distances and the clock rates emerge from space. And so when we consider relativity theory, both special and general relativity, we must start over with as a purely electromagnetic phenomenon, looking what happens electrically. And if you do that, you're able to explain all the general relativistic effects without using space curvature. Instead, the speed of light varies because the permittivity and permeability of space vary. And when you multiply permittivity times permeability, you get 1 over c squared, 1 over the speed of light squared. So the speed of light is not a primary constant. It's a secondary constant, or tertiary, actually. But I'll get into that in another video. And I have. So we can come up with all of general relativity as a purely electromagnetic phenomenon if we start with dimensions and clock rates being electromagnetic phenomena that emerge from a quantum field, which they are. And that gives us all the general relativistic phenomena involving photons. We don't have to worry about an equivalence principle because general relativity is electromagnetism. There's no equivalence to it. It's the same thing. It's just part of the same thing. And then the last part we have to consider is things like precession. which, while we can describe those as general relativistic effects, there are equations for that, that's not really what's going on. And we can tell that by thinking about what happens with an electrical neutral body, like a planet or star, or us. We can't exceed the speed of light. And as I said, the speed of light is due to permittivity and permeability. So ultimately, electrically neutral bodies are affected by the permittivity and permeability of space, limiting them to the speed of light limit. Which means that we, and every other object in space, is constantly interacting with the quantum field, which really should be no surprise. But what may be surprising to some people is the interaction is occurring in the same way electromagnetic interactions occur. When a body moves, it causes quantum fluctuations to rotate, and quantum fluctuation rotation keeps the body moving. And in this way, we have self-induction, inertia as self-induction. And so if we consider this all around, it actually leads to a force that obeys Maxwell equations, a force between electrically neutral objects that obeys Maxwell's equations. So this means the precession of tops, the precession of gyroscopes, the precession of planets like Mercury are affected by these electrically neutral Maxwell equation interactions. And I'll do another video on this. I call it the matter force because it's based on the amount of matter. You use the amount of matter instead of electric charge when you're doing this matter force calculations between electrically neutral objects. So when we consider gravity as a whole, everything we've thrown into gravity these days, we have first this Fatio Casimir effect, which causes electrically neutral bodies to be pushed together electrically. We have the general relativistic effects on light primarily that are due to the effect that matter has on the quantum field, where it causes the permittivity and permeability of space to change, which changes the speed of light, and clock rates, which gives us the general relativity effects. And then lastly, we have this electrically neutral Maxwell force that causes various forms of precession that are necessary in order to explain orbital motion of planets and stars and such. So it's actually a fairly complicated picture to explain gravity in its entirety because we've lumped so many things into it. But once we unravel it, we have a very clear picture that all of the phenomena that is lumped into gravity is purely electromagnetic. And general relativity never answers the question of what happens when two objects are in space and they're being accelerated by gravity somehow. Because they just say, oh, it follows the curvature of space. Well, what if they're not moving? Just start with two objects that aren't moving. They can't just follow the curvature in space. Something has to accelerate them. And what it is this electromagnetic pressure of the quantum field. That's how gravity really works. So gravity is an electromagnetic force. Well, I hope you like this video, and if you do, please like, share, or subscribe. Share it with your physicist friends who would be surprised by this. And then, if you want to learn more about it, I talk about this in my book, The Zero Point Universe, and then more in my books, The 100 Greatest Lies in Physics, and also my particle theory book, Goodbye Quarks, The Onium Theory. And I am a retired independent researcher, so if you want to support my research, buying the book helps me. And I also have a Patreon account if you'd like to do that. So thanks for watching, and I hope to see you in the future.